The title of my talk is Binary Associative Memory, a benchmark for neuromorphic hardware, or the unofficial subtitle is The Art of Neuromorphic Hardware. And I've done this work as part of my master's thesis at Bielefeld University. So the first question I should answer is, why should one want to use binary associative memory, which was introduced yesterday by Christoph, as a benchmark for neuromorphic hardware? And the simple answer is that this very simple associative memory model has a well-established theoretical foundation, which allows to calculate the information that can be recalled from the memory for a given data set. And you can, for example, see this here. So we have different data set sizes, and we can predict how much information can theoretically, under perfect circumstances, be extracted from the memory. The idea is to simply run this memory and on the various neuromorphic hardware systems and the simulator platforms, and to calculate how much information can actually be recalled when implementing this memory as a spiking neural network on those platforms. And the largest challenge is to actually run this network on those various platforms, like the neuromorphic hardware platforms, Spiky, NMPM1 and NMMC1. Then we have the emulator for NMPM1, which is the ESS, and also the software simulator Nest, which I use as a reference model. So to compare the hardware platforms against the software simulation on Nest. The problem is that there are small differences in the software layers between those individual platforms. So I wrote this abstraction layer called Pineless, which allows to use the very same network description and to run it on all those platforms shown here. And then I have this tool Pinem, which actually takes a description of the experiment that should be run and generates the networks, executes them on the hardware, and evaluates them, and then gives the user the results. So these results look like this. So here you can see the reference result for a two-dimensional neuron parameter sweep. And here we have the result from the NMMC1 system. And as you can see, there is very little difference between these two platforms. And on the left, you can see a very fast prediction measure. So you have to take into mind that each point in this image is a complete full network evaluation, which takes, depending on the platform, a long time. And this whole picture here is calculated in a few seconds, which allows to automatically select the neuron parameters in an automated optimization process. Here I have the same results for a little bit different experiment with the Spiky platform, and here you can see that that Spiky deviates very strongly from the reference Nest and also from the prediction. If you are interested in benchmarking neuromorphic hardware, come to my poster or read my master's thesis, which is somewhere on GitHub.